Okay, the rational zero test can give you more information on the zeros of a polynomial. What you're doing is you're picking out these rational numbers p and q. P is the factor of the constant term, so the number at the end with no x. Q is the factor of the leading coefficient, your number in front with the highest x, or the x with the highest exponent, the one that gives you your degree. So if I'm looking here, I want my factors of 8 over the factors of my leading coefficient, which is 1. So all my possible zeros are going to be in this list, and you always include the positive and negative. My factors of 8 are 1, 2, 4, and 8. Since I only have 1 as my denominator, these are all my options: 1 over 1, 2 over 1, 4 over 1, and 8 over 1. I do need to include the plus and minus on each of these. And what this tells me is that this polynomial is going to have rational zeros at any of these possibilities. Now obviously it only has a third degree, so it can only have at most 3. But here's your list to start checking. Find the rational zeros of this one. Let's start with our rational root test, our p over q. Okay, for this time I'm looking factors of 125 over factors of 1. So again, nothing else to divide by. Factors of 125, we're going to start with 1. It's not even, so it's not 2. Maybe 3. 3 doesn't divide evenly. 4, no. It is divisible by 5. So plus or minus 5 is a possibility. 6, 7, 8, maybe 8. Nope. I think the only other ones we come to are going to be positive, negative 25, and then of course positive, negative 125. So I've got 8 possibilities here. If I'm testing them, I'm testing to see if they are going to make my equation equal 0. So just plugging them into my calculator, I've got a list to go through and check. So I can check if plugging a 1 in for x. If I plug in 1, does that give me 0? Well, plugging a 1 in there, I would have 1 minus 15 plus 75 minus 125. I don't think this is going to come out to be working. Negative 64. So, not going to work. If we try negative 1, does that equal 0? And that will give me negative 1 minus 15 minus 75 minus 125. I don't think that one's going to work either. So we keep trying. So 5 is one of them that works. So I know x equals 5 works. And in this case, 5 is the only one that works. So 5 is the only rational zero I can get out of this. This means, since there's actually 3 here, the other 2 must be imaginary or irrational. Descartes' rule of signs can help you determine what kind of zeros you're looking for, positive, negative, or imaginary. What you do first is you take the number of positive real zeros is either equal to the number of sign changes that you have when you hop from a positive to a negative, or addition to subtraction. That can give you your number of positive real zeros. And then to find the negative real zeros, you substitute negative x and see how many sign changes you have there. So, for an example, we're going to jump. We have a change here. We change from negative to a positive, change again, and change again. So 3 changes mean I have 3 or 1 positive zeros. Okay, you always go down by an increment of 2, so if we had landed on 2, we would say a 2 or none. 3 changes mean 3 or 1. Now I look at f of negative x to figure out how many negative zeros I'm looking for. First, I've got to substitute that in there. And what happens when you cube a negative? It's going to stay negative, so this is actually going to become a positive 2x cubed. A negative squared is going to become a positive, so this is going to stay positive 5x squared plus x plus 8. And now you count your sign changes. Same, same, same. So there are 0 negative zeros or roots. So what I want you to think about on here is making a PNI chart. A PNI. Your number of positive real zeros, your negative real zeros, and your imaginary zeros. You always look at your degree. Your degree will tell me how many you're looking for. You're looking for 3 total. Since I could have 3 or 1 positive zeros, I'm going to put 3. If I have 3 positive zeros, I can't have any negative or any imaginary. If I have 1 positive, I don't have any negative roots right here, so 2 of them must be imaginary. These rows are going to add up to your degree. Our degree is 3. So here's my possibilities. I could have 3 positive roots, or I could have 1 positive root and 2 imaginary roots. And the only 2 combinations I can make. Okay, we're going to use our 2 processes to find all the zeros of this. First thing you need to notice is that all of these have an x in common. So there's one of your factors pulled out. 10x cubed minus 15x squared minus 16x plus 12. Okay, so this is one of your zeros. We're going to take that out from the very beginning. Now we just have to find the zeros for this guy. So let's look at how many sign changes. Here's a positive to a negative, and here's a negative to a positive. So I have 2 or 0 positive roots. And now let's look at f of negative x. And again, we're only looking at this part. I've already taken care of this guy. So this would be 10 negative x cubed minus 15 negative x squared minus 16 negative x plus 12. So negative 10x cubed. Remember, odd roots keep their sign. This is going to be a minus 15x squared. I'm not sure where that extra 1 came from. Plus 16x plus 12. Count your sign changes. Negative to a positive, here's 1. So there's 1 negative root. So now I know my PNI chart. I'm looking for 3. Remember, we already took care of that guy. Positive, I could have 2, or I could have 0. So negative, I can only have 1, and that would make my imaginary 0. Or I could have 1 negative here, and then I'm going to have 2 imaginary roots. Now here's my 2 possibilities. 2 positive, 1 negative, or 1 negative and 2 imaginary. Okay, seeing as how either of my options have imaginary roots, I'm going to go ahead and see what I can do to simplify this. I know I can bring out an x. And I did already try factoring that by grouping. It does not work. So what we have to look at now are my possibilities. What are my possibilities out of here? That's your P over Q. So my factors of 12 over my factors of 10. What are your factors of 12? 1, 3, 4. Oh, forgot them. Let's try that again. 1, 2, 3, 4, 6, and 12. Your factors are 10, or 1, 2, 5, and 10. So you have quite a few possibilities. Pulling these out, let me give you an example of what this whole list would look like. You could have positive, negative 1 over 1, positive, negative 1 over 2, positive, negative 1 over 5, positive, negative 1 over 10. And then I move on to the 2. I could have positive, negative 2 over 1, positive, negative 2 over 2, and so on, and so on. So it makes a very long list of possibilities. The easiest way, I'm going to say, is to look at your graph. See what you can find from the graph. If you can find any of these whole numbers or fractions, that's going to be your best bet. From the graph, I can see that it does cross at x equals 2. So here's this possibility right here, 2 over 1. What I'm going to do is divide that out. Since, okay, we've already divided the x out of the entire polynomial, now I'm going to take out, if I know x equals 2 as a solution, then x minus 2 has to be a factor. So I'm going to do that division. Put 10x cubed minus 15x squared minus 16x plus 12 in here. And I'm going to run out of space to do this division. I can move it up a little bit. Alright, I'm going to have to, what do I have to multiply by x to get 10x squared? So, or 10x cubed would have to be 10x squared. Multiply down. Minus 20x squared. Change my signs, combine, falls out. That'll be 5x squared minus 16x plus 12. So I have to have a positive 5x up here. 5x squared minus 10x. Change my signs, combine. Negative 6x plus 12. So I have to have a negative 6 up here. Plus 12. Change my signs, remainder of 0. If you don't get the remainder of 0, you did something wrong because the graph told you it should work. Now this is what I've worked my problem down to. X we took out from the very beginning. X minus 2 we just took out because we saw 2 on the graph. And this is my last factor. So does it factor like normal? Well, are there multiples of negative 60 that add up to 5? Maybe. And maybe not. So we're going to, it's a quadratic. I can easily use the quadratic formula. X equals negative b plus or minus square root b squared minus 4ac all over 2a. So negative 5 plus or minus the square root of, that would be 25 minus 4 times 10 times negative 6, 265 over 20. And so x equals square root 265. Does not simplify, so now I have 2 roots that come out of here. Negative 5 plus my square root of 265 divided by 20 gives me a 0.56. And you would not round, you want to list your zeros of this, but I'm just getting roundabouts where they're at. Negative 5 minus radical 265 divided by 20 gives me negative 1.06. The x out here gives me x equals 0. The 2 out here gives me x equals 2. So in my possibilities, I had Now we can see that we have 2 positive answers, 1 negative from our P&I chart that fit one of our possibilities. This one we took out from the very beginning. So here are all your rational zeros. Of course, you will need to include this part for the exact answer for these. I just wanted to see if they were going to turn out positive or negative.